Hello everybody. This is a video lecture on stereochemistry of Unit 1 in the Organic Chemistry 1 paper of MSc Chemistry course at Dr. MGR Educational and Research Institute. Let us first start with isomerism in compounds. How do we differentiate constitutional isomers in compounds or molecules? Now we can see here four pictures of chains. Now the first two chains represent branched one where the pendant or the dollar is present in as an hanging style. So we call that as a branched type. Whereas in the other two pictures of a pearl and the green color chain, it is a linear fashion where the pendant is not hanging but it is along with the continuous chain. So likewise in a compound we can differentiate a functional group whether it is a branched type or is in a linear fashion. Here we see two examples for position isomer and functional isomer. In the first picture where we see the position of the ball in the passing the ball game between the children, we can see the ball will keep passing between the children, and with respect to the child the ball possessing, we can see the position of the ball also varies. Likewise in position isomers, the functional group attached to the position of the carbon differs. In case of functional isomers, we see a difference in pendant as an example where the chain is the same, only the color of the pendant is different. Likewise in the functional isomers, only the functional group will be different in the two isomer compounds. To summarize what is an isomerism, compounds or molecules that have same molecular formula but different structural formula are called isomers, and this property they possess is called isomerism. Depending upon the type of isomerism, the physical and chemical properties of these isomers may or may not change. Since the arrangement of atoms in a molecule varies, the properties also will vary. Broadly, isomerism is classified into structural and stereoisomers. Structural isomerism is also called as constitutional isomerism. Now, isomers that show structural isomerism are called structural isomers or constitutional isomers, and isomers that show stereoisomerism are called as stereoisomerism. Again, we are going to see here about the constitutional isomerism. Constitutional isomers have different arrangement of atoms in a molecule. For example, we can see a classroom where the total strength of the class is going to be the same, but we are going to change the arrangement of students in the class. So we can see two pictures here. The first picture shows a different arrangement and the second picture shows a different arrangement of the benches and the students, whereas the total strength is going to be the same. The number of the students as well as the teachers and the benches, table, everything is going to be the same. Only difference is the arrangement. So this is a good example of constitutional isomerism. If the students are considered as atoms, then if total strength is to be the molecular formula, the seating pattern is nothing but the structural formula or arrangement of atoms in the molecule. So this property is called as a constitutional isomerism or structural isomerism, and the compounds that possess this isomerism is called as constitutional isomers or structural isomers. A brief about constitutional isomerism. It is further classified, subclassified into chain, position, function, metamerism, tautomerism and ring chain. So chain is nothing but the linear or branch which we saw in the first slide of pendant in the hanging style or in the continuous fashion. And second is the position isomer where we saw example with the passing the ball within the children. And functional isomers are two different pendants and the same chain attached. Metamerism is nothing but the number of alkyl groups attached to sides of the functional groups. That is going to vary. Tautomerism is nothing but the location of the proton in the molecule will vary. Ring chain is the molecule, either it is cyclic or non-cyclic. With respect to that, we will say whether it possesses isomerism or not. Few examples of constitutional isomerism are given here. For chain isomerism, N-pentane and isopentane is given. For position isomerism, 1 propanol and 2 propanol are given, where the position of the functional group attached to the chain is different. In case of functional isomerism, ethanol and dimethyl ethers are given as examples. For metamerism, diethyl ether and methyl propyl ether, where the number of alkyl groups attached to the either side of the functional group O is different. In case of tautomerism, ketoenol tautomerism is given. Other than this, enamine tautomerism also exists as an example. For ring chain isomerism, propene in a linear fashion and a cyclopropane are two examples. Now we will go into the other branch of isomerism, that is the stereoisomerism. And when we talk about stereochemistry, it is about the arrangement of atoms, molecules or ions in 3 dimensions. For example, when we have to draw a square, we just give the length and the breadth, which is going to be the same. Whereas when we draw a cube, we give the length, breadth and the width to say it is a cube. So that is a 3-dimensional model, whereas a square is just a 2-dimensional model. So stereochemistry is the chemistry about stereoisomers, where we broadly study about the physical properties as well as the chemical properties of those isomers. So it is studied in detail under isomerism in chemistry. The study of stereoisomers is called as stereochemistry. The compound that exhibit isomerism in 3-dimensional are studied here again. So the bonds of these stereoisomers are usually represented as thick lines called as wedges, which means they are towards us or above the plane of the paper or the screen. And thin lines or dotted lines represent either away from the plane of paper or the screen or behind us. The wedges indicate the bond is in perpendicular direction to the plane of the screen or the paper. Listed here are few references used to prepare this video lecture. By this we are ending the part 1 of unit 1 stereochemistry in the organic chemistry paper 1 of MSc chemistry course. Thank you.